Okay. So let us take up the second reconciliation here. So once you are given the reconciliation, the first task is to identify the values for a, b and d. Now if the second term of the recurrence is given as an exponent, as an expression like this, you have to write it as theta of some function n raised to d. If you cannot write the d with an integer, then you have to use big O. So n square can be written as theta of n square, and d is 2 here, which is an integer. So we can write down the values of a, b and d. So a is 4, b is 2, d is 2. So find then b raised to d. So in this case, b raised to d is also 4, same as a. So the formula is theta of n raised to d log n, which means d is 2. So t of n is theta of n square log n. Now if you see the first and second second reconciliation, you notice that the first term is the same in both. It's only the second term that's different, which is the time complexity f of n to combine the solutions. In the first case it is n, the second case it is n square. So if the time complexity to combine the solution increases, the overall time complexity also increases from n square to n square log n. Okay. Now let us do even further. T of n is 4t n over 2 plus n cube. So again we can write the n cube as theta of n cube and then find the values of a, b and d. So b is 2, d is 3, 2 raised to 3 is 8. A is less than b raised to d. If a is less than b raised to d, the formula is t of n is simply theta of n cube. So which is n to rise to d, which is 3, right? So that's why I said theta of n cubed. So if you keep the first term again fixed and increase the time to combine solutions, it increases to n cube, and the overall time complexity also is theta of n cube, so it also increases. Now let us go even less. So we increased from n to n square and n cube. So let us see what happens if the combining part is just a 1. So that's the time complexity to merge the solutions, so combine solutions. So once you have a constant like 1 or 2 anything, we can write it as theta of 1 in terms of the theta notation. So the recurrence becomes t of n is 4 times t of n over 2 plus theta of n raised to 0, where a is 4, b is 2, d is 0. b raised to d is 2 raised to 0 is 1. So comparing a and b raised to d, a is 4, b raised to d is 1. So the formula is if a is greater than b raised to d is n to the power log a to the base b n. So a is 4, b is 2, so n raised to log 4 to the base 2, and then we have, that's it, right? So it is theta of n square. So as you can see, if the time to combine solutions is just theta of 1 or it is theta of n, the overall time complexity remains as n square. Now if you look at this reconciliation, t of n is 4t of n over 2 plus 1 over n. So before applying master theorem, check if the recursion satisfies all the conditions that are needed for the hash function, sorry, for the function f of n. So here f of n is 1 over n, so you could write it as n to the power negative 1. Now you cannot write it as theta of something, because if you write theta of n raised to d, the d has to be 0 or positive integer. So f of n is 1 over n, which is not a polynomial. So master theorem cannot be applied for this reconciliation. So in exam, I could give you a master theorem that may not have the complete solution. So once you identify something like problem number 5 here, you should be able to say the f of n is not a polynomial, so Massey theorem cannot be applied. Any questions so far? Okay, so let us do 2 more problems on the Massey theorem, and then we'll move on. Okay, so look at this recurrence. T of n is 4 times T of n over 2 plus log n. Now it's very clear log n cannot be written as some theta of n raised to d, where d is an integer, because log n is a different function compared to n raised to anything. So we need to use the big O notation, right? So when you use the big O notation, we need to use in the format n raised to d also here, and pick a d that is the closest enough to log n as an integer. So the closest value for d to the log n function is d equals 1. So we have found the d term. It's going to be then T of n is 4 times T of n over 2 plus 1. Theta of n, sorry, I did not write it here. Let me write the recurrence. T of n is 4 times T of n over 2 plus big O of n. So n raised to d is 1, a is 4, b is 2. So we can write b raised to d, which is 2, and compare with a. A is greater than b raised to d. If a is greater than b raised to d, this is the formula we have. T of n is n raised to log a to the base b. So a is 4, b is 2, n raised to log 4 to the base 2 is 2 times log 2 to the base 2, which is 2. So it's big O of n square is the overall time complexity. Now the last recurrence, T of n is 6 times T of n over 3 plus n square log n. So again, we cannot write n square log n as theta of n raised to d, where d is an integer. So we will go for the big O notation. Now n square log n can be written as some big O of d. D is say 3, as small as possible integer value. We may say, why can't I write d equal to 2? If d equals 2, it becomes n square log n, which is greater than d equals 2. So I say d equals 3. So n square log n can be written as big O of n cube. So a is 4, b is 3, d is 3. So b raised to d is 3 raised to 3, which is 27, and a is less than b raised to d. 6 is less than 27. So which formula we should use? A is less than b raised to d, so T of n is simply big O of n raised to d. And d is 3, so T of n is big O of n cube. Okay, any question on this? So let me save this video.